Game consists of a circular board where the radius of the innermost circle is 7 centimeters. The radii of the subsequent circles are in AP with a common difference 7. The participants are required to throw the dart at the circular board, uh, and the prizes are won as per the region hit by the dart. Okay, so these were the situations which gave them some context to pose problems. There were two more games, but like it would take too much time for me to explain all of that. Then there were a few prompts that I gave them. So the prompts were pose as many mathematical problems related to probability as you can from the given situations. So I kept like I narrowed the scope of the problems to probability so that it doesn't become very overwhelming for them, and then try to pose problems of different difficulty levels because I wanted to ensure that they try their best to pose as many variations of problems as they can. And you can change the given information or supply more information to the given descriptions. So they could actually alter any of the conditions that were given in the problems and try out more creatively on what would they like. So I was expecting they might bring some contextual elements there. Okay, so this was about my tool. So now what did I find? So there is a book called The Art of Problem Posing, written by Brown and Walter. So in that book, they explain that there is a strategy called "What if not" and "What if" strategy, where what people while posing problems they do is they see what are the givens, then they try to modify those givens, or they keep the givens as it is, but ask different problems. So these are the two strategies they mention, and exactly this is what I observed, that children were doing exactly that. They were looking at the what was given, and they were trying to pose different kinds of questions from that, or they were altering the givens. Like in one of the questions, what they did was they said, okay, instead of the coins, we will take three die. And what we'll do is we'll roll all the three die, something like that. And then in that dart problem, what they did is they changed the shape of the board, and they also altered the coloring on the board. They said that alternatively we'll be coloring, and then if your dart hits like red color, then what will be the probability, or if it hits the alternate ring, then what will be the probability. So that was one thing. Then a lot of problems that they posed were very much similar to what they we observe in the textbook, also because children have been used to those textbooks from years, right? So those cannot be totally taken off from the context. So yeah, around 80 to 85% of the problems were from the textbook, but there were some very nice creative problems also which were not there in the textbook. One of the examples I've taken here. So what they did is we are taking three dice instead of tossing a coin three times. So Mukesh plays this game. He is given one chance. Let the number of the first dice be X, the second dice be Y, third dice be Z. Now prize would be given if participant draws 140 by the given equation, and the equation is x plus y times y times z is equal to 140. Now find the probability that the number of outcomes that will help Mukesh in winning the prize. So they thought of this question, and it was very interesting. Like it could be taken up in the classroom, and children can actually try out how they are going to go about this. And you don't see this in the textbook. You don't see children working on equations, working on some sort of solution set, and then looking at probabilities. So this is definitely a higher order question for them. Also, you can modify questions for children in the classroom along with them, where they feel that this question belonged to them and they actually created some good problem that engaged everybody in the classroom. Okay. Then I also saw that they were also engaging in problem solving while posing the problems. Not all the problems. Some of the problems they didn't know how to solve also. Like the problem I showed you before, they didn't know how to solve it, but they posed it. But there were a lot of problems that they were able to solve, and they were also specifically looking at, okay, I want this, I want a very weird number to come out of this solution. So I will create the variables in a way that that it results in a very weird number. So the person who is solving will get baffled. Oh my God, what kind of a solution I have got? So those were the considerations for them trying to solve the problems. Then students were able to pose problems related to higher level concepts. So also there was a card situation, and there was a ball was a situation where a mixture of balls was there. So they were also posing conditional probability related questions in which one event actually affects the probability of some other event happening. So they were able to get there, but they were not able to solve those problems. Then uh, students engaged more with situations where they seemed to understand the required concepts. For example, there was one group which did not know how to solve problems in terms of area, look at probability in terms of area. So that that situation they did not attend at all. So we can also gauge into what children are comfortable with, what they are not comfortable with when we see them looking engaging in this activity. So just 1 minute more I'll take. So one thing that I really observed was they were using a lot of mathematical terms. For example, at least, at most. I mean, we usually pinpoint to children in classroom a lot of times that, what does at least means, what does at most means. And but here when they are discussing with each other, they are clarifying to each other what they mean about some terms within the question that they are posing, and helping each other out. Uh, Yeah, yeah. So with posing problems, children brought some real life considerations to the problems also. So they were also posing problems ki this person should have very less winning probability. So I will give something which has a very less probability as a winning reward. I think that is very initial kind of a thought for them. But I think if this is taken up multiple times in a classroom, I think more contextual factors can be brought in with this. While posing problems, students showed consideration for the solver. Yes, a lot of children were empathizing with the solver and trying to pose some simpler problems. कि एक दो problems तो कम से कम कोई कर ही ले जो हमने किए हैं. And there was some कि this person should not be able to solve any of what I am posing. So those were the considerations also there. And finally, they also took up roles. Now, this was very interesting to me because this actually told me where problems came for them. Right? They were saying ki if I was a JE person, I would pose a problem like this. If I was a CPSC board exam paper setter, then I'll pose a problem like this. So for them, mostly problems were coming from some exam which sort of tested some of their ability, and which was a bit sad for me to see, because it was not some sort of a enjoyment endeavor that they were taking. I think that was it for the presentation. We can have the rest in the discussion itself. Yeah, yeah, it's done. Like, thank you. Thank you for listening so patiently. Um, um, I think I wanted to club that, but I didn't have that much of time. I wanted, yeah. Acha, before that. Mm. Yes, I thought about it because I see that problem solving and problem posing are very much interconnected to each other. And but I'm not sure if I would do it before. I might do it later also, like once they pose the problems and for refining and making the problems better. Or sometimes what happens is they will create a very generalized problems, then they will approach it through different simpler problems, like doing it in some cases where they take n is equal to 1, n is equal to 2, and then they reach to a some general problem. So maybe when they pose difficult some problems for themselves, and then if I follow up with problem solving, I'll understand more on how they thought about solving proposing it and then solving it further. Like that's what my idea is. I would like to discuss more about how it could be done, like before, and how could that support problem posing in some sense. Okay, so I didn't keep any time limit, and that was interesting to me that children were sitting without me telling them to sit for 2 hours continuously. They didn't even take a break. They were just discussing mathematics and those situations. So approximately all the groups took around 2 hours. They sat for 2 hours and they discussed and they posed problems. But that didn't correspond to how many number of problems they posed. So some of the groups even posed like lesser number of problems even when they took 2 hours, because their consideration for aptness of the problem was that it should be very unique, it should be very difficult. For some children the aptness was that we have to pose variations in problems. They might be easy, they might be difficult, we just need to pose as many problems as we can.
Would you have data as to the students who perform this activity were purely CBSE based or a combination of, competitive exams or purely JEE types? Would you know what kind of students like?
um, I had children from the commerce and the mathematics section, the commerce and the science section. That was a mixed group, and they were from CBSE. Yeah.
Just wanted to ask, was the lesson on probability already done by the students in the school and then you did this session, or was it not at all?
So the thing is, these were grade 11 students who had just passed their board exams, and the situations that I had kept were grade 10 level. So I was expecting grade 10 level probability they might be knowing, and I was expecting questions around those kind of concepts. So they had not done conditional probability by then. It was, I think, April, May. So that's why I ordered that kind of a question in a thing that it was a difficult and a higher level question for them because they had no exposure to it. Mm, I think I had 5 girls out of 15 students, but I was not very specifically looking at the gender aspect. But I saw that the girls were trying to moderate the group in a very organized manner. Like, because one of the groups, all boys were there, and they split into three people and they were working separately. They didn't collaborate at all. And I saw more collaboration happening when girls were there, and they were taking responsibility and roles and distributing those roles. That was fun. Uh, so there were two girls in one group, one girl in one group. It was like that. Okay. So one anecdote that I would like to share is, so one of the boys came because he wanted to bunk his physics lesson. And when I showed him this task, and the other two guys are sitting, and he's also sitting, and he's like, "Oh, ma'am, but I don't feel like I want to do this." Then I said, "Okay, you try. If you don't feel like, then you can go and you can send somebody else." And he sat there for 10 minutes. Actually, two of them were feeling like they want to go. So one of them lost all motivation and went, and he sent somebody else. But then what happened? These two were very enthusiastic. The one who came and the one who was previously there. Then this third boy, because of their enthusiasm, became very enthusiastic. And then they started collaborating and posing problems. So it was about whether they wanted to engage in something new and explore what I had brought for them. I didn't tell them whether have high ability in math or you don't have high ability in math. That was not the criteria.
Survey on problem posing, and I want to know that what would be your next step, like after that, next, I mean, if you really want that it should be implemented on a, large scale.
Yeah, so when I was doing this, I really found that this is really helpful, especially to provide enough amount of challenge to all kinds of students in the classroom. I mean, you can give actual individual attention to students if they are posing problems as per their levels. So during this work only, I was mostly getting very attracted towards the idea of designing some sort of pedagogy around it, and then testing it with how it works with children, looking at their ability. So I would like to work around how to develop some concrete pedagogical practices along with some material which could be sort of a you know I would say inspiration guide or something which could help somebody to look at it and think for themselves what they would take from it in their classroom. So I think I would work more into something which would reach directly to the teachers, speak to the teachers, and they could take that into their classroom.
So much. Actually,
Thank you. Thank you, everyone, for being so patient.
yeah. Okay, go ahead. I'm so sorry.
Well, definitely, this is one a very good idea. I look forward to it. Try to like take it. Yeah, like we can always try and find, modify and make it better. Thank you for the suggestion. I think one thing that I can take from this is that problem posing really works well when children are collaborating in some sense. I think if they're individually working, yeah, so but they are collaborating as a team. Yeah, some sort of competition is happening, some sort of collaboration is happening. Yeah, yeah. That's really motivating for them. Yeah. Yeah, I agree to that. Yeah. Yeah.
So, no, one more. Okay, I'm sorry. We, I need to manage the time also. So, be a quick question. Okay, great. Please introduce yourself. Yeah, thank you. So just wanted to give you a few points also to think about. I think it's a really wonderful study, and you can, of course, extend it much more. Uh, 2 points. First is regarding this assessment of what you have done in terms of problem posing. If you can come up with a framework of what were the different levels of problems that were posed. You said some were at general level, some were at much more deeper level, higher order thinking, and also what understanding of probability is reflected in their problems that they had posed. Because I mean, it can be a very good activity that the students can do in the classroom, and the teachers can use that to assess their understanding of probability itself. So, I mean, these are also some of the aspects that I would like
Thank
you
you.
to think
Thank
of.
you.
Yeah.
I look forward to this.
Yeah. Okay. So we are a bit short of time. No, we can manage, I think. So let's invite the second presenter, Chitra Kumari. Her title is Innovations in Mathematics Teaching and Learning Experiences and Narrative from the Classroom. She is from Disha India Education Trust. Come here, Chitra. So our presentation is up. You have 15 minutes for presentations, and then we followed by 10 minutes of discussion.
Sure. Good afternoon, everyone, and thank you for giving me this opportunity to present. My topic is Innovations in Mathematics Teaching and Learning Experiences Narrative from the Classroom. Can we go on to the next slide, please? Yeah, so I will mostly be focusing about the classroom experiences, the different voices, and the innovations of teaching and learning in the classroom. Yeah, please. Uh, yes, once more. Yeah. Coming to the context, so this study is done in a community school in Pada. It's in Karnal, and it's a CBSE school, English medium. And for the particular class that I took, it was class 4. There were 17 students, 10 of them were boys and 7 girls. It was co-taught by me and another teacher from the school. So I was a visiting teacher there. I generally go for 1 month, teach there. And I also get to learn teachers practicing there as it is an experiential learning school. The focus was for the study, I took a topic of volume, liters and milliliter, and the chapter was called Jugs and Mugs. And coming to the other details, the class was conducted for 10 days, and the objective was to make them understand the measurement topic and how they can understand in life what milliliter and liter really is. And this topic was selected based on what they were doing already in the class, so I just took up the next topic. Yeah, so these are the 10 classes that I took, and every class had a particular objective. There were different uh, first learning objectives, then uh, we use multiple resources to go ahead for each. So, 1 minute. The first one was the we introduced small and big volumes. So I didn't want to just start with what is a liter and a milliliter. So we went ahead and wanted to ask student how much is a little or a large volume is. So then we also did storytelling, and the story was in the book. We extended the story to some of the aspects which were not there in the book to, further take the level which was not there in the book. Then we further familiarize with the units liter and milliliter as it was already covered in the story. Then we understood small volumes, and then we did a lot of activities based on it. So some of the resources we use were dropper, cap of bottle, syringe, beakers, cups, bottles, and so on. So most of these resources were mostly available in school. There were a science lab, so science resources we used beakers from there. The cups were available, from home we brought, and we only had to buy the droppers. Then in the further classes, we tried to understand how to convert milliliter to liter and liter to milliliter. Then we compared different kind of volumes, understood what large quantities are. We did a lot of real life problems. And finally, there was a pen and paper based assessment towards the end of the class. Next slide. Yeah. So these are the engagements that we did. We did a video, a couple of storytelling days, then we had a lot of hands-on activity of continuous assessment. For that, we use worksheets, practice time questions on real life examples, and we were using books and the content of the book for giving homework because largely we were doing things which were outside the textbook. And then there was, of course, a lot of real life examples, and yeah, classroom discussions were happening. Next slide, please. This is the breakup of how much resources we use. So 46% was largely the book resource we used, and the 53% was outside the book, and these are the bifurcations. Yeah, next slide. So this is a snippet of one of the classes that I took. Um, Here why this problem was taken. So when we try to understand the unit liter and milliliter, though it is a tactile phenomena, we can see it, yet uh, it has to be done to know how much that quantity is. So we try to take this problem in the class. Suppose a doctor has asked you to put eye drop for 2 months. So how many bottles of 5 milliliter eye drops you will buy? This was the problem. And what they had to do is they had to find out how many drops of water are there in a 5 milliliter of bottle. So we gave them a few materials. We gave them a dropper. We gave them a empty bowl and a glass of water. So we wanted them to measure, and we provided them the dropper of 1 milliliter and 2 milliliters. So they had to fill that with water and measure how many drops are there. So while they were doing this, so this we didn't expect that would come. It was difficult for them to measure 1 milliliter, provided we given them the dropper. And that was because whenever they were putting in the water, the air was getting in, or they were not able to fill in zero point 0.1 ml at once. So then, we told, okay, first fill in 0.5 ml and then see how much water is there and then measure that. So some of them were getting answers 8 drops, 9 drops, 10 drops, 11 drops, like that. And it was varying every time they were doing it. So the thing was that they were not able to generalize that every time they measure 0.5 ml, there will be fixed number of drops coming. And here we had to intervene and then, do it and show that they can either, uh, get the quantity in 1 ml, which is if they're doing it 0.5 ml twice, then it will be 10 in 10, 20 drops. So they can directly multiply 10 to 20 into 5, or they can do the repeated addition to get the answer. And then, we finally concluded and got the answer. Okay. No, please, previous slide, please. Yeah. We said that there are, so there are 60 days. So ideally 60 drops will be needed. But then one student stood up and said, Ma'am, we have two eyes. So we need to put double the amount. So there'll be 120 drops. So that means we won't, if we buy only one bottle, it won't suffice. We need another bottle for it. And that was like an aha moment for me because I didn't also come up with this. Yeah. Next slide, please. So different narrative. So the slide is about the voices and the narratives. Uh, Previously, when I started this chapter, a lot of boys were actively answering. They had a lot of prior concepts about liter and milliliter, and they were able to connect it with the real life examples. But on the other side, the girls were sitting quiet and they were not very active in the class. And so I was very mindful of this thing in the classroom, and tried to do different things and engage girls. So here in the next slide, there are some students' voices. It's in Hindi. I'll also translate. क्या किसी कार में 200 liter petrol जाता है? The teacher is asking, is there any car that can like that has a capacity of 20 liters of petrol? And sorry, 200. Yeah. So, because the boys, this question is coming from a boy. He's thinking that it was a multiple choice question that I posed during the assessment, that if you had to fill your car and you had to fill the petrol, and there were few options like 20 milliliter, 5 liter, 200 liter also. And then they had been knowing lot of cars, and they said, okay, there are some kind of vehicles. They might have confused the trucks and of the bigger size of vehicle which might have that capacity. So I didn't argue much. I just said, ask them to you find out and let me know. So here students prior knowledge was getting tested. Then in second scenario, this is a girl student, and I've met her outside school and I witnessed a drain there. So I asked the student that how much water do you think is coming out of the drain? Is it in liter or milliliter? And she was confused and she said milliliter. And gradually, I posed the same question in the class, And that time we had covered a bit of milliliter, liter concepts, and then she answered, "Ma'am, it will be liters because there's so much of water flowing, so it can't be in milliliter." So student gradually applied a formal knowledge in the real life example. Now, in another activity-based classroom, we had a uh, cup of tea. I mean, there was a cup, and it was empty. And I asked the students that how much water will fill in here. So the student said 250 milliliter, 200 milliliter, 130 milliliter, and it was random. And then we showed, okay, we had a beaker of 25 milliliter. We started pouring water. When we did it for 3 times, they saw that it's almost half full. So then they were able to understand, okay, Miss will be 150 milliliter. So here, students' abstraction getting tested, and they're reaching towards abstractness. Sorry, exactness. Next slide, please. Yeah, next slide. So we did continuous assessments one by one. Yeah. So this is one of the questions I gave them. It's a calendar, and there are so it's me. I gave them the question that if you had to calculate how much liter of milk was taken over the whole month, so find out like add. I mean, there were 4 questions to it, and they had to find out in week 1 how much milk was taken, and similarly in week 2, week 3, week 4, like that. And they also had to convert that milliliter into liter. The second is a video. We showed another video to explain again through a video, an audio visual experience to help them understand the different quantities. Third, please minimize it. Minimize it. Next one. Yeah, so this is another worksheet. Minimize it further. So here, when I was giving them the worksheet, I tried to be mindful of, uh, because I wanted to include girls in it to give things which they can relate to. So a shampoo bottle or a hair oil and other things which they could, and a perfume also, to understand that these can be also in milliliters and liters, and it's very much there in their houses. Next one. Then there were few other worksheets like that. Next one. This one is particularly given when I had to take their assessments. This was a pen and paper assessment. So these were the different questions covered in it. Next one. Yeah, so we started with this very uh, questions: water tank, rain of drop, water bottle, cup of tea, coconut oil, cooking oil, face cream, and other things. So are these too little, medium, or too much? So we initially discussed that what you will tell this as. Next one. And then finally another worksheet. Yeah, next slide. Yeah, so innovative approaches of teaching and learning. The next slide, please. Uh, so we started with checking the background knowledge, which was informal in the initial stage. We brushed them, and we tried to convert their knowledge from approximation to abstractness. It was a gradual process. You know, it took a lot of days to make them understand. And since volume is a tactile phenomena, therefore we use a different activities, hands-on activities. We use concrete materials to make them visualize it, which can lead them towards abstractness. And it took longer time, and it was a gradual process. Next slide, please. Yeah, this study, when I was doing it, I was not thinking to present it in a case, and so it was not recorded in a systematic manner. Though I used abstracts, worksheets, and students' response, uh, and individual students' progress was also not mapped. Next slide, please. Yeah. So, though the teaching and learning method was innovative in its approach, so what? Next, please. So, should we call it a non-conventional classroom? Can it be replicated in any kind of school? Can such engagement be possible with the students? And finally, is it something every teacher should do and every teacher ought to be. Thank you. Okay, I'm open for the rest. Yeah. Mm-hmm. Uh, I'll have. Mm-hmm. Yeah. As in different, so we did it in a lot of a discussion form. We did discuss about not like physical objects were not there, but verbally we discussed different kind of objects and if they could be categorized in milliliters and liter. Huh. Yeah. Yeah, yeah. Yes, it was done. Yeah. Hmm. 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 So there were questions in the worksheets like that. They had to, so in form of worksheets we did, but not much verbally, or we didn't try to ask such questions. But they had this understanding that even a Coke bottle, which is small, will hold a milliliter of Coke, but if it is a larger bottle, it will be in liters because, they had this understanding that Coke bottles, if they have to buy a bigger one, it will be in liters. That was there. Students didn't do any kind of research. They had to basically understand that till what volume it will be in milliliter, and beyond that, it is a bigger volume, so that will be in liter. So we focused on milliliter a lot so that they could, have that kind of understanding. The yeah, there was a confusion in that where we said that lead, the students only told that the milk is no, no, they, from their understanding, they knew that we say kg of milk, not liter of milk. But because we know that the liquid is in the form of liters, so I mean, we told that formally to them that it won't be in grams, it will be in liter. Yes, ma'am.
Continuation to her question, what I want to know is, were the children kind of taught something before they were exposed to these kind of exercises? Were they given some knowledge before we took information from them about how to measure and how are small quantities measured and how are large quantities measured?
So initial two classes we started with first about having this understanding of how you will say a waterfall. Will it be little water, a lot of water, or a tank of water? So we started from there, little, very little, average, and then a lot. So from there we went to the book, and then there was a story of I mean, there was a party, and there they came, and they were served some amount of kheer. So 50 liters of kheer an elephant is having. That was a starting point to an ant who was only having 1 milliliter of kheer. But then, how much is that 1 milliliter? That was not clear in the book. So, we had to do the exercise, a hands on exercise to make them further understand that how this is coming in. Yeah. Yes, please.
there was some variability, like 1 ml would be like 3 or 4 or something. So students were made aware that there is some uncertainty of measurement here. But when you take it to paper and say now we'll multiply it to 60 days, 30 days, and we get an answer, did they like was there some discussion about like should we trust this answer, or like how did they deal with that uncertainty going from like the thing done in front of them going to pen and paper?
There was a lot of confusion when we were putting it in pen and paper. Like I said that, yeah, the it was very much still abstract. Like if I'm measuring and it is not consistent, and actually it remained still a confusion for the whole part of the day. We could not make them understand that how it, if you do it again and again, it has to be the same. So we lacked there, and this also came up again as a problem when we were doing the buckets and mugs. So how many mugs of water we will pour so that the bucket will be filled, if it is the bucket is of 10 liter and we are pouring with a mug of 500 milliliter. So there also this gap was seen, and I still wonder that how, I mean, I would like to know that how this gap would have filled.
So if I can say something here, see, one needs to understand, how when we are doing measurement, what kind of approximations are there. We have to, and whether it would really be same at all points, or or there will be some error in measurement, and what is the scope of this error when we are taking small thing to measure and when we are taking a bigger thing to measure that, and how much of that error we are able to ignore, and which one to consider. There are lots of questions that are coming when we are doing this activity of measurement itself. And maybe not all discussions can happen with fourth standard students, which you did, but there are certain things that definitely one needs to have a discussion about what they are understanding from this process, and whether it will always exactly be the same amount of drops, especially when we are putting drops, or there is this variability, and how to manage this variability, understand it. Maybe you can take an average or so, and then
Yeah,
extrapolate to the number of dips. I mean, this is just a suggestion for you.
right.
Others can also respond. Yeah.
What I am going to say is more of a concern. Like you have taken both standard.
Hmm.
In our state, I'm from Punjab actually. In our state, in primary schools, we have ETT teachers. Most of them, they are not from mathematics background. So explaining the things the way she did can be done by a maths teacher only, which I have experienced. So do you think if this thing is possible in all the schools with all the children where the teachers they are not from mathematics background? This is my concern. How we can take these things to them? Because I remember the chapter you have taken, jugs and mugs. I had taken it for my actual research years back. In our state also we had this book. But my concern was that schools around me they had ETT teachers and they were not able to take up all the concepts they were covered in the book. Conversion of units, it was there in the book, but it could be seen only by a maths teacher, a person from a mathematic background. So it was my concern. So I just wanted ki in the book should be self-explanatory for the teachers who are not from the mathematics background. So this is my concern. Like we people all are mathematic background people, and we know all these things, and we people are doing all these things in the school in this way only. But what about the children who are not getting such experiences? How we can do something for them?
My inspiration for doing this kind of activity was, I always think like from a child point of view. I don't think like a, like really like a mathematician, but I think like if I had to convey something to my students, how best I can do that. And I thought if I can make them visualize, do some hands-on experience. And for that, I don't really have to be an expert in mathematics. I just have to be creative in my thinking, for which we don't need to be, mathematical experts or something. So, uh, Okay.
In that story, there are
Hmm.
like instances where they have to convert, and you can think because you have that mathematical background. You know that you have to teach conversion here. The method will be obviously creative because you have that creativity in you. I am like my question is to all sitting here. Like if in that particular school the teacher is not aware of all these concepts, he will simply do the questions which are given in the question form only. He may not be able to make the child visualize that story and understand all the concepts. You can answer.
Yeah, even I want to answer. Go ahead. I think let's open this.
It's just an experience that I
Yeah.
want to share with you, ma'am. Like till grade 5, we have mother teacher system. So obviously we cannot get teachers who are expert at all the domains. So what we do is we try to incorporate members from each domain. For example, if there are three sections, I'm just giving you an example, and there are two teachers in the class, so six people. So one would be from English, one would be from Hindi, math, science, and then whenever we make plans, we collaborate. So that collaboration is very important and peer group observation, and that's how we learn. Because in primary we focus on integration. We don't focus on subjects. So that integration comes in and all heads come together. They prepare a plan and then we execute it. Here, very important role is of the process where the mentor is also sitting, collaborating, where the teachers are also observing each other. We learn from each other. In fact, we learn a lot from the children. Rather than we doing it and then they say, can we do it like this? हाँ, ये तो मेरे दिमाग में ही नहीं आया. So, those kind of things happen a lot. So that really helps us grow
I
better.
think that's a very valuable input that you have provided. I just wanted to check if Maruti KJ Sharma is here. Maruti KJ Sharma, because he is the next presenter. Okay. Then we can continue the discussion for some point. See, this problem of, you saying, I mean, you have formulated this as a problem that, only mathematics teachers can do and non-mathematics teachers may struggle with it. And this is perhaps your assumption, I would say at this point. So, I mean, this is a situation which is very common across India of out of field teachers teaching mathematics, not only at elementary level, but we are aware that they are teaching at middle school level and secondary level also. In this situation, do we say that they need to have a mathematics background to address these problems in the classroom, or do we need to think about the teacher preparation pre-service level itself or in-service level professional development programs to provide these resources to teachers to be able to, think in this manner in the class? And somewhere it is also reflective of the what we say is common people's understanding of different units. Why do we not have this as a common knowledge amongst all of us? Why do we call this as a knowledge which is very specific to mathematics? This is something, a knowledge which is so necessary in our daily lives. Then why are we calling this as something which is specific to mathematics? This is what my viewpoint is, but I can open this discussion to the whole room itself because we don't have the next presenter and we can continue. Yeah, or we are.
I think the common knowledge that we just talked about, we often see if we go to screen and they all have it.
Yes.
Yes. And they're not trained in mathematics and etc. So, I mean, there is a way that people learn, perhaps not in classroom, outside. She was making was there should be a lot of supporting behavior.
for the motivation of the teachers. So working in small, taking small steps with the teachers would be easy because if they are motivated, as ma'am also said, then that would reach eventually to the learner. Actually, so, ma'am, the thing is, our education system is marks driven, right? And when in a classroom, a teacher is teaching, if he is not a creative person, he is just there teaching the students, helping them to attain marks. So he or she will not be bothered about the way he is giving the concept. He is simply teaching the child, helping him get points, and the child is not aware what he is getting. Right? I am just teaching the way I can. Right? So the thing we want the child to get, like those who write books, those who give materials, their point, what was there in their mind while writing the book, while giving the content, was something else, and what the child got was something that the teacher had in her or his mind. So this is my concern actually. Like, marks, they are the driving force behind every teaching in the classroom.
So I, yeah.
Continue. I want to get back to what Vishnu was asking.
Yes, go ahead.
And can I?
Yeah, please go ahead. I think it would be interesting for all of us.
So this is about the uncertainty and the
Yes.
in the this lot. So that's also related to the question that I asked at the beginning. Just that you've taken this, standard measurement, right? Milliliters, liters as the main focus of your research and whatever. Right? Now, of course, if you're talking about class 4 children, these abstract measures like milliliters or grams, they're very difficult. And you know, when you work with experiential ones, right? I mean, like a glass packet now, like something that they can directly attach meanings to. Of course, it's very hard then to do with eye drops and do, which is what was the example that you were illustrating. And then this kind of error propagates and error multiplies.
Yeah.
But we are used to handling a whole lot of measurements informally,
Yeah.
where we also have intuitive ideas of how the larger things come, right? So I'm wondering whether this research can also be tied with where experiential measures are used and whether children actually have built up intuitive understanding.
And
And
starting
then
from
with the standard measures and calculations, because thousands, those are difficult concepts. So
and what does
do you
it
think,
mean to multiply it? Multiply it for 60 days.
when do you add and when do you multiply?
Yeah. All those
So
at fourth
I'm
standard
wondering
level is
whether
difficult.
a study where the intuitive measures can also be studied along with experiential measures that might help.
I think I agree with you. This could have been taken up in that manner, and a bit of flexibility. I think due to the time also we didn't had was, when they were not able to come to 5 ml of the whole addition, we generalized and then we gave the answer. But it.
And then 0.5 ml at
Hmm.
fourth standard. I don't
Hmm.
think they know the decimals at that level so much to be
Yeah.
able to understand.
Hmm.
8%. If we do it wrong,
Yeah.
I don't know how many of us will be able to very precisely pinpoint.
Yeah.
How much is the 0.5?
So we didn't wanted exactness also. We wanted them to abstract, because it will vary and we don't want that kind of
But what I mean,
precision.
we are starting the question to all of us,
Hmm.
right?
Yeah.
How many eye drops would go? I don't
Yeah.
know how many of us would have
Yeah. Hmm.
estimated anyway.
is telling to someone that you had last time on 10th you had taken 1.5 liter and on 20th take 2 liter. Like that he may make complete something. And even though he not pick up any pen or pencil, and yeah, he calculated. The illiterate person has doing this job. You have to just put the that research in your that research, like how much your family is selling the milk and how they added it. These things should be unclear, and then they can completely understand the idea, I think.
Yeah.
So this was actually tried to be done. So when I asked the students about the milk, the boys of the class were very active and they sort of had this prior knowledge. But though the girls were having cows and buffaloes at the home, they were not able to even tell that how much one bucket of will have the milk. And so there was a gap in a huge gap in both of their knowledge. So that's why I gave an example of this 200, 250 milliliter of milk bought on certain days, and then there were certain days where we skipped. So only like the boys who were having, prior knowledge of that were able to come up with the answer first, and accuracy with accuracy also.
Maybe then one can probe further whether it is, boys are participating more in the activities of selling vis-a-vis girls. I mean, this is something that has to be
Yeah.
understand, because in only in those, what are those contexts in which you have to say something that how much this quantity is.
Hmm.
So how many of those kind of situations students are getting an exposure to, whether they are getting that in daily life or not, maybe that kind of. Any further questions, comments, please?
I don't want to put up a question, but we can add on to these things that when we should think about the uncertainty, not maybe in fourth standard, but we can extend it to 10th standard or 11th standard when they are studying statistics. You can open up this discussion for statistics that if you try 50 times, you
Hmm.
get the average of this as one drop will measure this much.
Hmm.
Then you can also connect it with the correlation factors, how much dispersion is there. That can be taught with this process. And we have done the same thing in our school about the probability when we taught in 10th standard. We made 10 children to toss 10 times. And then we recorded the response. Then we explained that as the data becomes larger and larger, we approach a proper classical probability. So that statistical data, or you may also teach that you are calculating for 2 months. So then it will be a good approximation. But if you are calculating for 2 years, it will be more closer. I think that could be a open with this.
Yeah, that's the statistical error, right? But this is systemic error.
Yeah.
So,
But if we, I don't know, I may be very small to answer this, but maybe if we increase the data or if we increase the experiments, then maybe we can be closer to what is actual.
No,
Maybe,
it may.
maybe. I'm not sure.
Okay. Yeah, just respond to that, and we are going to close because I think there is going to be a long line for lunch. Yeah.
So my concern is that when we are introducing these activities, and students see this uncertainty, and then immediately after that we want them to mathematize in with a concrete terms, right? In a very certain terms, say like, after 60 days it will be. You're talking about the science of dealing with uncertainty. You're asking them to teach it 6, 7 years later, but learn all this certain mathematics before. So how do we want to have this experience of uncertainty, but then to pick up this certain mathematics. So that is what I was posing as a problem. So this doesn't
Yeah,
address.
it doesn't, but it is just an extended version.
Yeah. So I think with that we close the session. Let's give a good hand to big hand to Ruchika. Yeah. And with that we adjourn for lunch. I think lunch has been
Thanks
great.
to both the presenters for sharing their valuable knowledge and ideas with us. Your contributions have truly enriched this conference. So now I can see all the tired faces. So it's time for a lunch break, and lunch has been arranged for all of you at the dining hall. And beside this, I also request everyone to assemble for workshops as after lunch breaks.
30 p.m.
Yes. So till 2:30 p.m. there will be lunch break, and after 2:30 p.m. the workshops will be held in both the computer labs. Workshop 2 will be in computer lab 1, and workshop 1 will be in computer lab 2. You can check the booklets also. Yes. There are systems, ma'am. Okay, okay. Okay.